Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in a previous session, we had seen the properties of matrix operations. So that is nothing but properties of matrix addition, properties of scalar multiplication of a matrix, properties of matrix multiplication, and etc. So in this class, we'll be going on to the next topic. So the next topic for this class would be transpose of a matrix. So before we get into transpose, we'll just have a very quick recap, whatever we had seen previously. Okay, in the previous class, we saw properties of matrix addition. Okay, which all laws were here, students? Commutative law, associative law, existence of additive identity as well as existence of additive inverse. Okay, so these are the four properties which are associated with matrix addition. Moving on further, next we saw the scalar multiplication of matrix. Scalar multiplication of matrix, and here we saw two laws again, K of A plus B and K plus L of A. So these both laws were associated with scalar multiplication of matrices. Apart from this, we also saw the properties based upon matrix multiplication, and there, okay, matrix multiplication, the laws associated with these are associative law, commutative law, and existence of multiplicative inverse. Okay, so these were the things which we had covered in the previous class. So just we had a very quick recap. Moving on to the next topic for today, that is nothing but transpose of a matrix. Now, what is the meaning of this transpose, students? I think I have explained you this before. Once again, we'll just have a look. Transpose is nothing but, so this is not a definition. Okay, I'm just writing what we have to do here, the operation I'm writing here. Okay, writing the rows as columns and vice versa. So for example, we will consider one small matrix, students. So for example, let matrix A of order 2 cross 3. So which is equal to 1 minus 1 0 2 1 1. So 2 cross 3, right? 2 rows and 3 columns. 1 2 3. Now if we have to write the transpose of this matrix, how do we represent that? We can either write A dash, or we can also write A to the power of t. Both means the same, which means the transpose of the given matrix. Write the rows as columns. So what is the first row, students? 1 minus 1 0, write that as a column. 1 minus 1 0. The second one is 2 1 1, write that as a row again, column again. 2 1 1. So now what would be the order of this matrix? 3 rows and 2 columns, correct? So 3 cross 2. So this is nothing but the transpose of a matrix. Means what? Writing the rows of a matrix as columns and columns as rows, vice versa. Okay, there are few properties based upon transpose of a matrix. So properties of transpose of the matrices. So these may be verified by taking suitable examples. For any matrix A and B of suitable order we have. So the very first one is, so these are the four things which you have to remember again. Okay, these are the properties of transpose. So A transpose, the whole transpose is equal to A. Okay, K A, the whole transpose is equal to K multiplied with A transpose. A plus, or you can also include minus here, students. Okay, A plus or minus B is equal to A plus or minus the whole transpose is equal to A transpose plus or minus B transpose. The last thing, AB the whole transpose, here it is becoming what, students? Matrix multiplication. Okay, AB the whole transpose will be equal to B transpose into A transpose. So these are the four properties which are important under transpose of a matrix. So we will just quickly verify the first one. A transpose the whole transpose is equal to A. Now on this side, students, what did we have here? Here we had A, right? So this is A. Now what did we get here? A transpose we got, that is nothing but A dash. Now transpose this A dash, you will be getting what again? A, correct? So A transpose the whole transpose, A transpose the whole transpose. So transpose this. Again write rows as columns. So 1 2, right? It is a row, write it as a column. 1 2. minus 1 1 minus 1 1 0 1 0 1. Now check whether this is equal to A. 1 minus 1 0, 1 minus 1 0, 2 1 1, 2 1 1. So therefore this property is proved, right? A transpose the whole transpose will be equal to what, students? A. Correct? So here this property is proved. Similarly, so the same thing you can take A, whatever we have taken here. Okay, verify whether this is satisfying. It will satisfy. Even this will satisfy. For example, B you can take. So here we have taken what, students? 2 cross 3, right? B also you can take of the order 2 cross 3 because while adding the orders must be same. Okay, so here you can take 1 1 0, 1 1 0. So you can take this as B, check whether this is right. Okay, obviously you'll be getting this as correct. And the next one we have again A cross B. Now while multiplying, okay, the number of columns of A must be equal to the number of rows of B, then only the matrix multiplication is applicable and we can carry out the matrix multiplication. So you can assume some random examples and you can check these properties and I'm sure it will definitely satisfy them. Okay, moving on to the next one. I have taken few examples, okay, based upon today's topic, that is transpose of a matrix. The very first example, A is given to us, B is given to us, okay, we have to verify that. So three things we have to verify. A transpose the whole transpose, which we did now just. Okay, the second one is A plus B the whole dash is equal to A dash plus B dash. So students, three properties are being proved here. So three properties we saw, right? See this, and I think this one is being proved. So this one is left out. You can try this, students. One example we are taking and we are proving almost three properties of the transpose. Okay, so let us start with this example. So if A is equal to 3 root 3, so what would be the order of this, students? 2 rows, 3 columns. So it will be 2 cross 3. Correct? Now we will find out this part. A transpose will find out. So A transpose can be written as, write the rows as columns. So this will become 3 root 3 and 2. Correct? 3 root 3 and 2. Row is written as a column. 4 2 0. 4 2 0. What is the order of this matrix? 3 rows, 2 columns. So that is nothing but 3 cross 2. So this part is done. Now transpose the whole part again. You have to be getting A. So A transpose the whole transpose. Now again, students, write the rows as columns. 3 4 is the row, correct? Write it as column 3 4. Root 3 2. Root 3 2. 2 0. 2 and 0. What is the order of this matrix again? 2 rows, 3 columns. So 2 cross 3. Is this equal to A? 3 root 3 2. 4 2 0. So this is equal to A. Therefore, the first property has been proved successfully. Okay, moving on to the next one. The next second one, what we have to prove here. A plus B the whole dash is equal to A dash plus B dash. We'll find out what is A plus B first. So A plus B can be written as matrix A 3 root 3 2 and 4 2 0 plus B matrix 2 minus 1 2 1 2 4. The sum of this will be equal to how much, students? So order will be same only, right? Because so this is again 2 cross 3. This is also 2 cross 3. Orders are same, which means we can add or subtract. Now add these both. 3 plus 2 is nothing but 5. Root 3 minus 1 is root 3 minus 1 itself. Okay, we'll write it as it is. 2 plus 2 is equal to 4. 4 plus 1 is equal to 5 again. 2 plus 2 is 4. 0 plus 4 is 4 again. What would be the order of this matrix? 2 rows, 3 columns. So 2 cross 3. This is our what? A plus B. But what do we want? A plus B the whole dash. So therefore, A plus B the whole dash can be written as rows as columns, students. So 5 root 3 minus 1, 4, 5, 4, 4. 1, 2, 3. 3 rows, 2 columns. So this is 3 cross 2. We got our what? LHS. Understood, students. Now we have to find out RHS, A dash plus B dash. So what is A dash? We'll change the color here. A dash. So we'll directly write A dash plus B dash. So write A dash, students. Transpose this 3 root 3 2 and 4 2 0. 3 root 3 2 4 2 0 plus B dash. Transpose this matrix 2 minus 1 2 and 1 2 4. So the sum of this can be written as, so here only you can write the sum. 3 plus 2 is 5, 4 plus 1 is 5, root 3 minus 1 as it is. 2 plus 2 is 4. 2 plus 2 is 4 again. 0 plus 4 is 4. So what is the order of this matrix? 3 rows, 2 columns. Are they both same? Check. 5, 5. Root 3 minus 1, 4. Root 3 minus 1, 4. 4, 4. 4, 4. Therefore, we can write a plus b the whole dash is equal to a dash plus b dash. Hence, proved. So we have proved the second sub question in this question. So this is also done. We are remaining with the last one, students. What is that? Very simple. Okay, k dot b the whole transpose is equal to k into b transpose. Now students, what we have to do is first we'll do whatever is there inside the bracket. We will multiply the scalar called as k with the matrix b and then take the transpose. Alright, we'll do the left hand side first. Okay, here we'll be doing it. So k dot b is equal to. So just multiply k with each and every element of matrix b here. So that will become 2k minus k, 2k, k, 2k, 4k. Kb the whole transpose. So this will give us 2k minus k, 2k, k, 2k and 4k. This is our what, students? LHS. We'll change the color here again. Now we'll find out what is RHS. So here it is b dash into k. So what is b dash, students? So here we'll write b dash is equal to 2 minus 1, 2, 1, 2 and 4. Now multiply k with this, k into b dash. So that will be equal to 2k, k minus k, 2k, 2k and 4k. What did we have here? This is our RHS. That is our LHS. Is LHS equal to RHS? 2k, k minus k, 2k, 2k and 4k. Therefore, LHS equals RHS. Understood? So we have also proved the very third one. Kb the whole dash is equal to k into b dash, where k is any constant. We have kept it as k only. You can put any number instead of k. Anyways, we have proved all these three sub questions which are related to matrix, a property of matrix which is called as transpose of a matrix. Alright, moving on to the next example. One last example we'll be doing and we'll be stopping this class. Okay, so this is an example, the next example. If A is equal to minus 2, 4, 5, 3 rows, 1 column, 3 cross 1, 1 row, 3 column, 1 cross 3. Verify that AB the whole dash is equal to B dash into A dash. We'll take the left hand side, students, first. Can we matrix multiply them? Yes or no? Yes, we can matrix multiply. Why? Because the number of columns in A is equal to the number of rows in B. That criteria is getting satisfied. Therefore, we can matrix multiply. What would be the order of the product? The order of the product would be 3 cross 3. So we'll write LHS, which is equal to A dot B. Correct? Only A dot B will find out, which is equal to. So we'll start matrix multiplication. First row into first column, minus 2. First row into second column, minus 6. First row into third column, 12. 4 ones are, 4 threes are, 4 6 are, minus 6. Okay, 5 ones are, 5 threes are, 5 minus 6. So we got 3 cross 3. This is only AB, students. We'll write AB the whole transpose, which is equal to minus 2, minus 6, 12, 4, 12, minus 24, 5, 15, minus 30. Transpose, students, writing the rows as columns, rows as columns, rows as columns. So this is our what? LHS. On this side, we'll be doing the RHS, B dash into A dash. Okay, so we'll change the color here, students, again. So B dash again, what is B dash here? So B dash would be, we directly will write B dash into A dash. So B dash would be 1, 3, 6, 1, 3, minus 6. Okay, this is B dash. Order of the matrix, 3 rows, 1 column, 3 cross 1. Okay, into A dash. Rows as columns, so A dash will become minus 2, 4 and 5. So 1 row, 3 columns. Can we matrix multiply them? Yes. Why? Because the number of columns in B is equal to the number of rows in A. So therefore we can matrix multiply. What would be the order of the product? The order of the product would be 3 cross 3. That is B dash into A dash will be equal to 3 cross 3 matrix. Now multiply this, minus 2, 4, 5, minus 6, 12, 15, and this would be 12, minus 24 and minus 30. This is again what, students? 3 cross 3, and this would be our RHS. Check whether LHS equals RHS. Minus 2, 4, 5, minus 6, 12, 15, 12 minus 24 minus 30. So it is very evident that LHS is equal to RHS, which means what? Which means the properties of transpose, whatever we have seen, and matrix multiplication, whatever we have learnt in our earlier classes, all those are right because we are getting LHS equals RHS. Understanding, students? So these are the problems related to transpose of matrix. Transpose of matrix is one of the important topics under matrix. So here we'll be stopping the class. We'll be moving, or I'll be seeing you in the next class with the next topic related to matrices. Until then, take care, students. Share, like and subscribe to Vista's Learning. Thank you.